Good morning, friends. I am Dr. DN Pansare, Assistant Professor, Department of Chemistry, Devgiri College, Aurangabad. We today discuss the topic is mass spectroscopy. Mass spectroscopy is very useful technique in the organic chemistry when we synthesize new molecules. Okay, that time we must know that the molecular weight of different types of compound. That's why today we focus on the mass spectroscopy. Before beginning this mass spectroscopy, let's we discuss some contents: introduction, basic principles, theory, brief outline of instrumentation, ion information, and types, fragmentation process, fragmentation pattern, fragmentation characteristic in the relation to the parent structure and functional groups. Mass spectroscopy. We see the first definition of mass spectroscopy. Mass spectroscopy is one of the primary spectroscopic methods for molecular analysis available to organic chemists. It is the microanalytical technique require only a few nanomoles of the sample to obtain characteristic information pertaining to the structure and molecular weight of the analyte. It is not concerned with non-destructive interaction between molecules and electromagnetic radiations. It involves the production and separation of ionized molecule and their ionic decomposition product. And finally, the measurement of the relative abundance of the different ions produced. It is thus a destructive technique in that the sample is consumed during analysis. In most cases, the nascent molecular ion of the analyte produce fragment ion by cleavage of the bond, and the resulting fragment pattern constitute the mass spectrum. The mass spectrum of each compound is unique and can be used as a chemical fingerprint to characterize the sample. Basic principle of the mass spectroscopy. Let's we discuss about the basic principle. What is the basic principle of the mass spectroscopy? Mass spectroscopy is the most accurate method for determining the molecular mass of the compound and its elemental composition. As I told you that the mass spectroscopy is useful for new compound or known compound, we can easily find out its molecular weight, or impurities molecular weight also we can easily find out. In this technique, molecules are bombarded with a beam of energetic electrons. The molecules are ionized and broken up into the many fragments, some of which are the positive ions. Each kind of ion has a particular ratio of mass to charge, that is the mass by charge ratio value. For most iron, the charge is 1, and thus m by z ratio is simply the molecular mass of the ions. The additional energy of the electron is dissipated is breaking the bond in the molecular ion, which undergoes fragment to the yield several neutral or positively charged species. This fragmentation may result in the formation of an even electron, ion, and radical. The various positive ion thus formed can be accelerated and deflected by the magnetic or electric field. The deflection of ion, however, depends on its mass, charge, and velocities. For a given charge, velocity, and the deflecting force, the deflection is less for a heavy particle as compared to that of a light one. Thus, number of beam, each containing ion with the same m by z value are obtained. These beams are then made to the strike against a photographic plate, where not only they appear as a separate line, but the intensity of each peak is also recorded. The clear visual presentation of mass spectrum is usually obtained by the plotting m by z value against relative abundance, assigning the most abundant ion base peak in the spectrum as 100%. Though organic mass spectrometry is routinely used along with IR, NMR, and UV for the structural determination, its basic theory is different from the others. In mass spectrometry, no characteristic selective absorption of the radiation is involved, as in the case of the other three methods. Secondly, in the mass spectrometry, the compound undergoes irreversible chemical change, unlike in the others, where the change are a reversible physical change. The mass spectral reaction are much more drastic than usual chemical reactions. This is the principle and instrumentation of mass spectroscopy. This is the very good graphical presentation of the mass spectroscopy. It's showing principle and how it's work. Friends, today we see this diagram is first this arrow shows here. This is the vaporized sample is inserted in this region. In this region is ionization or ionization chamber is there. Then here in the three slits, acceleration is there. In the dotted line is means that the particle is coming in this region. These are color two electromagnet are shown here, and in this region the electron beam are deflected into the three steps. Again, it's come from the straight line is that is here to vacuum pump, and some are detection here. Then it amplified in the large scale, and we get the spectra here chart recorded or in our computer system. Basically, we can see here deflected three stages, stage 1, 2, and 3, or stage A, B, C. These are some electrons are deflected and some electrons are coming at the straight line. Only that particle will be analyzed and we get the mass spectra. So we discuss step by step one point in briefly. Ionization. The atom is ionized by the knocking one or more electron off to give a positive ions. Mass spectrometer always work with the positive ions only. Please remember that mass spectrometer always work with positive ions. This is the diagram. Here we can see ion repeller. First vertical line is ion pillar. Here vaporized sample is inserted. This is the electrically heated metal coil. Heat the sample or increase the temperature here. Then electron trap here. This region is electron trap and analysis it. Electrons, this dotted line means electrons are goes to here. Then this region is trap the electron. This dotted line shows means positive ions. The positive ions are coming in this region. The particle in the sample atom or molecules are bombarded with beam of electron to knock one or more electron out of the sample particles. To make a positive ions, most of the positive ions formed will carry a charge of +1. These positive ions are pursued out into the rest of the machine by the iron repeller, which is another metal plate carrying a slight positive charge. Acceleration. We discuss what is meant by acceleration. The ion are accelerated that they are have to some kinetic energy. Here we can see here three vertical line, that is the final plate. These are the intermediate plate and this is starting plate. Three plate is there. Ionization chamber at plus 10,000 volt energy, and it's coming into this region, and here ion beam. then it is easily accelerated and identified. The ions are accelerated so that they are all have the same kinetic energy. The positive ions are repelled away from the positive ions or ionization chamber and pass through three slits with voltage in the decreasing order. The middle slit carries some intermediate voltage and the final at 0 volts. All the ions are accelerated into the finally focused beam. Deflection. The ions are then deflected by the magnetic field according to their masses. The lighter they are, the more they are deflected. Please remember that the ions are then deflected by the magnetic field. According to their masses, the lighter they are, the more are deflected. The amount of deflection also depends on the number of positive charge on the ions. The more the ion is charged, the more is get deflected. Here, mixed ion stream here, this dotted line starting, we can easily understand. These are ion stream A, stream B, and stream C. Three parts coming here of the mixed ion beam: ion stream A, ion stream B, and ion stream C. This is the electromagnetic or electromagnet. This color or colored diagram showing electromagnet is there. Different ions are deflected by the magnetic field by the different amount. The amount of deflection depends on the mass of the ions. Lighter ions are deflected more than heavier ions. The charge on the ions with the two or more positive charge are deflected more than one with only one positive charge. Detection. The beam of ion passing through the machine is detected electrically. We can see here metal box, metal to the amplifier, ion stream. In enlarge of this diagram from here, these are positive ions. Green color shows positive ions and red dot shows electrons. Only ion B stream make it right through the machine to the ion detectors. We can see the previous diagram. Here three line is there: stream A, stream B, and stream C. Only these stream B is coming out a straight line. That's why we have mentioned here only one stream B make its right through the machine to the ion chamber. The other ions collides with the walls where they will pick up electron and the neutralize. They get removed from the mass spectrometer by the vacuum pump. When an ion hits the metal box, its charge is neutralized by an electron jumping from the metal on to the ions. That leaves a space amongst the electron in the metal and the electron in the wire shuffle along to fill it. A flow of electron in the wire is detected as an electric current, which can be amplified and recorded. The more ion arriving, the grateful the current. Fragmentation process. This is the most important pattern in the mass spectroscopy, that is fragmentation process. Bombardment of the molecule by an electron beam with energy between 10 to 15 electron volt usually result in the ionization of the molecules by removal of one electron, that is molecular ion formation. When the energy of the electron beam is increased between 50 to 70 electron volt, these molecule ions acquire a high excitation, resulting in their breakdown into the various fragments. This process is called fragmentation process. Then types of ions. If fragmentation is occurring, then there are some parts or types will be formed. That is molecular ion, parent ion, fragment ion, rearrangement ion, multi-charge ions, negative ions, and metastable ions. We can see step by step in briefly. So let's first discuss molecular ion or parent ion. When molecule is bombarded with electron in the high vacuum in mass spectrometer, it is converted into the positive ions by loss of an electron. These ions are called as molecular ion or parent ion. M plus E gives M plus 0 plus 2 electron, where M represent the molecules, that is the M plus represent the molecular or parent ion. The order of energy required to remove electron is as follows: sigma electrons greater than non-conjugated pi system greater than conjugated pi greater than non-bonding or lone pair of electron. This is the order of energy required to remove electron is follows. Means sigma bond is require more energy when we remove one electron. Then we know that sigma bond is strong. That's why we need more energy to remove the electron. Then non-conjugated pi system, then greater than conjugated pi system greater than non-bonding or lone pair. It's meant that lone pair of any of the atom is very easy to remove the electron, like alcohol amine. Okay, if we bombarded the phenol molecules, then lone pair of the present on oxygen, it is very easy to remove the electrons. Many of these molecules, ions, M plus, disintegrate at 10 raised to minus 10 to 10 raised to minus 13 second to give a positively charged fragment and a radical in the simplest case. If some molecules ion remain intact long enough, about 10 raised to minus 6 seconds to reach the detector. Most molecules shows a peak for the molecular ion, the stability of which is usually in the order aromatic greater than conjugated cyclic polyenes greater than alicyclic greater than N hydrocarbons greater than ketones greater than ethers greater than branch chain hydrocarbons greater than alcohol. Characteristics of the molecular ion. Molecular ion is observed if molecules ion remain intact long enough 10 raised to minus 6 seconds to reach the detector. This peak gives the molecular weight of the compound. The molecular ion peak is usually the peak of the highest mass number. The molecular ion M plus has a mass corresponding to the molecular weight of the compound from which it is generated. Thus, the mass of the molecular ion M plus is an important parameter in the identification of the compounds. Significance of the molecular ion. Molecular ion peak gives the molecular weight of the compound, that is M by Z of the molecular ion is equal to molecular weight of the compound. For example, C2H5 plus, that is the M by Z is 29, that is the ethyl molecule gives the molecular weight of the ethane. Fragments ion. When energy is given to the molecular ion during electron impact, further cleavage takes place and ion of the lower mass number known as fragment ion are produced. That is M plus gives M plus plus M2. Rearrangement ions. Rearrangement ion are the fragment whose origin cannot be described by the simple cleavage of the bond in the parent's ion, but are the result of the intramolecular atomic rearrangement during the fragmentation. These are the probable due to the recombination of the fragment ion and known as rearrangement peaks. Prominent peak in the spectrum of the diethyl ether occurs at M by Z 31. This is due to the ion CH3O positive, which is formed by the rearrangement of the C2H5O plus ions. Multi-charge ions. Sometimes ion may also exist with 2 or 3 charge instead of usual single charge in the mass spectrum. These are known as the doubly or triply charged ion. They are created as follows. That is M plus plus electron gives M plus 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 3 electron. Means When electron is removed, for example, one electron removed, then plus charge, plus one charge is coming. When three electron is removed, then m plus three charge will be coming on the molecules. Negative ions. Negative ions means what? When electron is get, then it divided into the two parts, a plus plus b minus. AB plus electron gain, then AB minus. Means what? When electron negative parts, positive ions predominate in the electronic impact ionization because of greater stability. The negative ions are not very useful in the structure determination. The formation of the negative ion is very rare, but this can be produced in the three ways like this. Metastable ion also is very important. Fragment of parent ion will give rise to the new ion daughter plus either a neutral molecules or a radicals. M plus 1 gives M plus 2 non-charged particle. An intermediate situation is possible. M plus 1 may decomposes to M2 plus while being the accelerated. The resultant daughter ions M2 plus will not be the recorded at either M1 or M2, but at position of the M plus as a rather bored, poorly focused peak, such an ion is called metastable ion. This is also ion source chamber, metastable ion formation in this middle region. Again, this part of the magnetic field here detected. This is the simple schematic diagram of the formation of metastable ions, molecular ion, and we get the spectra of the mass molecules. Nature of the metastable ions. Metastable ions have the lower kinetic energy than the normal ions, and metastable peak are smaller than M plus and M plus 2. Peak also broader. This metastable ion arises from fragmentation takes place during the flight down to iron rather one ionization chamber. Molecular ion form in the ionization chamber do on the of the following. Either they decomposes completely and very rapidly in the ion source and never reach the collector as in the case of the highly branched molecules ion lifetime less than 10 raised to minus 5 second, or they survival along with each collectors. Okay, thank you, friends. I think you get much more idea regarding uh, regarding the mass spectroscopy, and you useful for the study. Thank you very much.